I'm sorry, I just realized that I stopped it. I'm not sure. But we're going to do this many times. So at least let me say this one more time, because I messed up. I stopped it right now, so it's not a long time ago, but I don't remember when. So the exact area is the limit of the Riemann sum, where this is the base times the height. And it's the sum from I equals 1 through n. So now we want to find the exact area under f of x equals x squared plus 1 on 0, 2. And we need 3 preparations. And I was saying that we know that the result must be a number between 3 and 7, and most probably close to 4.5. Okay. I think I hope I didn't miss more than that. Okay, now, so 3 preparations. Preparation number 1 has to be delta x first. So the definition is b minus a divided by n. This is the interval a comma b. Of course, we've used that for intermediate value theorem, the mean value theorem, Rolle's theorem. That's always the same, a comma b. So b is 2, a is 0. 2 minus 0 over n. So this is 2 over n. N is not given to us now. N is something that will approach, is a number of subintervals that will approach infinity. We don't have a fixed number for n. Preparation number 2. Preparation number 2 is something called xi. Because this one depends on the position. What do you mean? Okay, here's what I mean. x0 is here. x1 is here at 0.5. So x1 is 0.5. x2 is 1. x3 is 1.5. x4 is 2. And so on and so forth, because they're n, right? So xi. So in order to find xi, we have to look at the interval 0, 2. So this is delta x, the width of the interval, of subinterval. This is delta x, this is delta x, this is delta x. This is delta x, this is delta x, this is delta x. Delta x, delta x. What am I showing here? The first point is 0 plus delta x. The second point is 0 plus twice delta x. This one. The next one is 0 plus 3 delta x. The next one is 0 plus 4 delta x. And so on and so forth, till I get to the last one. So xi, anywhere, if the first one is 0 plus delta x, the second one is 0 plus 2 delta x, the next one is 0 plus 3, the next one is 0 plus 4, what do you think xi will equal to? 0 plus how many delta x's?
Infinity.
One more time.
Or I.
No, it's a lot. It's a lot. And paying attention is not easy here. So let's do this one more time. x1 is 0 plus delta x. x2 is 0 plus 2 delta x's. x3 is 0 plus 3 delta x's. x4 is 0 plus 4 delta x's. What about xi? This is very important to remember because everything hinges on this. So again, what about xi? Xi is 0 plus how many delta x's?
Oh, I delta x.
Is that clear? And this is true for everything. If this is 1, this is 1. If this is 2, this is 2. If this is 3, this is 3. If this is I, this is I. So this is always the same formula. So xi is 0 plus I delta x, but I have to replace delta x by 2 over n. So xi is 0 plus I delta x 2I over n. Of course, I'm not going to write it like this. This is 0. 2I over n. So I determined delta x. I determined xi. So I have delta x. I have xi. But now I need this piece. F of xi. So remember f of x is x squared plus 1. F of xi is f of 2I over n. Can anyone plug in 2I over n here and tell me what to write?
Wouldn't it be 2I over n squared?
Exactly. 4I squared over n squared plus 1. Excellent. Okay, I do have now all three preps. 1, delta x. 2, xi that I need to plug in f of xi. So now the exact area is the limit as n approaches infinity from the sum from I equals 1 through n from delta x, which is 2 over n, times f of xi with parentheses, of course, 4I squared over n squared plus 1. We talked about the summation notation. If this is a constant, it does not depend on I. It doesn't change ever. It will be put in front. Limit n approaches infinity 2 over n. Now, we talked about the properties. The summation of ai plus the summation of bi. So the sum from 4I squared over n squared plus the sum of 1. But I know what this is. This will immediately be replaced by how much? Exactly. And my target is to remove this quickly from there. Notice another thing here. This piece is a constant. It does not depend on I. It's 4 over n squared times I squared. It will go in front. Limit n approaches infinity 2 over n. 4 over n squared, the sum of I squared from I equals 1 through n plus n. But I know a formula for this is the ugly one. Is the n plus 1 to n plus 1 over 6. That will replace the summation of I squared. Almost there. 2 over n. 4 over n squared. I will always distribute these two. 2n squared plus 3n plus 1. n, 2n squared plus 3n plus 1 divided by 6 plus n. And I will simplify an n with an n. I can simplify a 2 with a 2. Limit n approaches infinity 2 over n. The least common, let me write it one more time so you can see what it is. So I have 2n squared plus 3n plus 1 divided by 3n and plus n. Yes, this needs a 3n. So limit n approaches infinity 2 over n times 3 over n, 3n I meant to say, 4n squared plus 6n plus 2 plus 3n squared. So limit n approaches infinity. The denominator is 3n squared. 3 plus 4 is 7. 7 times 2, 14n squared. 2 times 6, 12n. 2 times 2 is 4. You either say, I know, same degree over same degree has to be 14 over 3. Or you say, I don't know. I don't believe anything. L'Hopital's rule. Limit Sn approaches infinity from 28n plus 12 over 6n. You can say again, I don't know, I don't believe anything. Limit n approaches infinity from 28 over 6, which is still 14/3, as mentioned before. So the exact area is 14/3. And this number has to be a number between 3 and 7. I guess I messed up my pages. Where was my 3 and 7? Here it is. This has to be a number between 3 and 7. And this is 3, so it's 4 point blah, blah, blah. Yep. Still with only 2. And this is the exact area under the graph of f of x equals x squared plus 1 on the interval 0, 2. If this is velocity, then my total distance is 14/3. If this is marginal profit, then this is the total profit between 0 and 2, and so on and so forth.